Thank you all for coming out. My name is Andrew Trubkowski. This is Atmo Many. We're going to talk about mapping visualization and analysis using the Python API. And we're going to sort of dive into a whole bunch of topics. The first thing we're going to talk about, and I think it'll be very beneficial for a lot of everyone here, we're going to talk about some Jupyter basics and how you can get familiar and some important shortcuts and inline methods that you can use to enhance your experience as you do analysis and what you go through. Then we're going to talk about what the Python API is, do a quick getting started for anybody who doesn't or hasn't used it yet, then dive into some mapping. Then we'll look heavily at the spatial dataframe. Then we'll do visualizing raster data, working with non-spatial data and how to visualize it. Because often you get data from other systems that aren't geospatially enabled, and that's very important. So how do you tell your story not just on a map, but through other methods as well? And then finally, we're going to do sort of a longer analysis of what you can do with the spatial data frame. So you don't have to be pigeonholed in with what the geometry engine is. You can implement your own algorithms and do your own analysis. And then we'll take questions. So Jupyter basics. Jupyter Notebook is an environment that allows you to create, share, and use live code. The presentation you're seeing right now is a Jupyter Notebook. Everything that's running is running live. I get to go in and edit it and rerun the cells. It has many useful applications, including geographic analysis, data cleaning and transformation, simulations. You can use it for machine learning and visualization. It's also really good to share your logic that you write with other users within your organization. So not only it supports full LaTeX, and it also supports math text, so you can even use it to write a book if you wanted, or write your thesis or whatever you want to do. So two important things that you need to know is how do you enter edit mode and how do you enter in command mode. Command mode allows you to do things like create cells, and edit mode is pretty self-explanatory, allows you to start editing the current cell that you have highlighted in your notebook. So it begins with, you start using one of those commands. Right now we're going to focus on command mode. These keyboard shortcuts will save you time from going up to the upper menu when I show you in a minute. And they'll allow you to create cells, move them up and down, change the type from markup to code, and also run your code. And two very important shortcuts, if you don't get anything else out of this, is Alt-Enter and Control-Enter. Each of these run your code, or they run the current cell. Control-Enter is interesting because it allows you to split your current cell. So if you run Control-Cell, wherever the cursor is, it'll split it into two at that point. And Alt-Enter will run and then create a new cell underneath it. Another important topic is using inline, and this allows you to use your matplotlibs and your panda data frames plotting and actually get them to show up instead of just seeing the object coming back. So here what we're doing, or what I did, is I import matplotlib and I rename it as PLT, save some character line, and then I use that %matplotlib inline. And what you're going to see that allows us to do is allow us to take any data and plot it, and it shows up in your notebook. If you didn't, you would just get what you see on the top right there. You would just see that little matplotlib dot lines 2D object and a little code after that. And then and just to show that you can do a little better plotting the same data, you can fully configure with matplotlib if you didn't realize, and any other plotting thing where you can generate a new figure, set your title, define your X and Y values, set a limit to sort of shrink everything down, and then set simple line symbology and labels. And this will become important later, and we'll be going back to this, but I just want you to take note of that syntax on plot. So I'm going to switch over for a second, and this is going to do famous last words. I'm going to try doing live code on stage. So we're going to take some syntax here, and we're going to show you how Markdown can be useful. When you run this, you'll notice that the percent signs that I have allow you to do additional emphasis. So it starts out title and then subtitle, and then it gets even smaller all the way down. And you can also make words bold and italicized. And this allows you to give greater meaning to the information that you're providing. And you can put emphasis on words. Instead of just having inline notes within your code when you share it to people, you can say, I'm doing this, and emphasize certain parts of your documentation by making a bold or italics than anything else you would do in a traditional, maybe Word document. But you can directly associate it with code. It's powerful. It gets your message out there, what you want to do. So to run it, Shift-Enter, and it runs. Next, we can enter the command line mode by pressing Escape and highlight the slide, and we can create a cell above it by hitting Escape and then A, and it creates a cell above. And other useful things you want to do is you can hit Escape again and get a new cell below, and you're ready to code in it. By default, it's set to decode mode. Any cell that you don't want anymore, you just highlight, and you can press Escape and X, and it'll delete it. If you want to change the type to markup, where you can do latex again, you just hit Escape on your highlighted and M, and then you can start writing something in that thing. This is Shift-Enter to run it, and now you have simple markup. To change it back to code, you can highlight that same cell and press Escape Y, and now you're back into code mode. So if you accidentally change as you type, you can go back to code. The next part I want to show you is how you get help, and this applies to beyond just our module, any of them, anything that you run in here. But you can do a simple import, and then for any function that you need more information on, you can do your gis.content.search and one question mark. Oops, excuse me. This is why people don't do live code on stage. We're going to take this, and help is going to pop up in the window on the bottom, and all the information about the inputs shows up. If that is not good enough for you, on the right-hand side on the screen, you can see there's a close and a pop-up. And the pop-up will produce it all on a whole new HTML page, so you can further look at it and to make sure that your information is correct. Furthermore, if you want to get really in deep dive inside of our API, you can do a double question mark, and this will allow you to look at the underlying source code. The same thing happens, it pops up. But more than just the help, you'll get the actual code that powers our search behind it. So if you don't think something's wrong, we want you to participate and help us fix it. That's how we use this project. It's open, and it's a community-developed product. It's more than just us. So that's why we allow that to happen. So we're going to go back now after that little demo, and we're going to talk about what is the Python API. So the Python API is a library, essentially a module that allows us to hook into our WebGIS. You can script and automate your workflow processes, and you can be as specific to tailor for your role within your organization, or you can open it up to enhance everyone across your whole organization. It supports content publishers, analysts, people who use big data, data scientists, power users and developers. They can leverage this module to make their own tools that they need. And it also allows administrators to manage users, roles, groups, and content. Getting started, just real quick, I want to show you, if you're unfamiliar, to connect into your enterprise system, you first import, you do a from ArcGIS.gis, and you import the GIS object, and then you pass in either your credentials, and we support a whole host of login methods, You can use PKI, Windows Authentication. Basically, if you can do it in Portal, you can log in with the GIS object to your enterprise through Python. So you don't have to do anything special. You don't have to make a special named user for ArcGIS Online if you're using SAML or anything like that. So common GIS tasks, once you have your GIS created, is searching for content. This is how users can start using information in their workflows and analysis tasks. Here we use the GIS content.search and we look for some content owned by Esri outside of our organization. We get back this colored pencil map, web map, and it's actually a base map that you could use in your own organization. Next, we're going to look at adding content. Adding content allows you to, you can take all your shape files and all your file geodatabases and your SD files that you have, and you can, depending on whether it's a Portal enterprise configuration or an ArcGIS Online enterprise organization, and you can start publishing this information out, and people can start consuming it. So how do you do that? It starts by adding the item. You fill in some basic item properties that are required by minimum, which is a title, type, and tags. Tags can be, you need at least one of them. So it can be one to many. They're descriptions of your words. These are how people are actually going to start finding your content. You pass in the path to your zip file, and then it's added to Portal or your enterprise. Right now it's just a flat file. There's really nothing special that's happened. We haven't published it. So now to publish that content, you can just turn around and take that item that you just added and you can start calling publish. You publish content and it can be as simple or as complex as you want. Here I wanted to show that you can customize some backend, so I added some publish parameters to my shapefile that I'm publishing by adjusting the max record, stating that I have static data, and changing the name of the underlying layer that I put on there. Also, I wanted to ensure that only users can query this data. I don't want to by accident have them editing or anything like that. So I want them to use users. So now I'm going to hand it over to Atma, who's going to start talk for the next section. So are you ready, Atma?
Oh, yeah.
Five. Yep. Do you?
Yeah, 5.
Yep, 5, right?
Cool.
Yep.
Hey, thanks, Andrew.
All right, thanks.
So let's start. Okay, let's get into visualizing spatial features using the ArcGIS ecosystem. There are so many different ways of doing it. As you've been long-term users of ArcGIS platforms, ArcGIS softwares, you know that we have so many different kinds of renderers and so many different ways of visualizing spatial data. But I want to start with the most easiest and the quickest way of doing it. And the way of doing it where you need to write minimal lines of code but still get good maps so you can proceed with the rest of the work that you're doing. So for that, I want to introduce smart mapping. What smart mapping does is you just give the data and you tell ArcGIS the kind of map you want to make, and it takes the decisions for you. It tries to find what class breaks to use, how to split and slice your data up, how to find the breaks between your the values in your variable, and how to assign colors for them. And it will also take into account the base map that you're using, and it will try to find what color suits best for that base map, and it will try to use the color scheme. We'll start from there, and then we'll get into hand it back to Andrew, who's going to tell us if you want to write your own custom renderers, how you can use the latest version of the Python API to accomplish that. And then I'll come back. We'll look at spatial data, feature data, and using smart mapping. We'll look at feature data using custom renderers, and then we'll change gears and look at how to visualize imagery data. And then we'll really change gears and look at non-spatial data and how to use third-party mapping and plotting libraries in Python. There are so many of them, we wouldn't have time to cover everything, but I'll try to pick some of the most popularly used libraries, and I'll just give you a sneak peek of those. So with that, let's start with smart mapping, and let's start with line features. So this is standard code. I'm trying to import my GIS library, making an anonymous connection. I'm just using public data sets, so I don't have to sign in for this example. Let's pull up a map. It's just one line of code, gis.map, give it an extent, zoom level, you get a map. Let's go ahead and search for USA freeway system. And if I want to add it to my map, all I need to do is map1, this is the map object that we just created here, dot add layer, give the item, and just like that, you have USA freeways. This is fully interactive. I can go ahead and zoom to any level, any extent, and you see that layer starts to render. So we can do better than this. How can we visualize this particular layer better than just with a single color? So let's try to see. Before we get into such kind of details, we need to understand what the distribution of data is. We need to understand what all columns are present and what kind of values are there. What is the data type of those columns? So we need to start exploring the data a little bit before we can choose what type, how to visualize that layer. So let's go ahead and call the layers property on this item. We have two different layers. For now, let's just pick the first one here. What I'm trying to do is trying to print out the different columns, the different attribute columns, and the data types. There is an object ID column, then I have a bunch of strings, and here I have distance in miles and distance in kilometers, both in number column. So number columns are really great if you want to use in these renderers. So let's go ahead and choose one of these. And what I want to do here is do a class size renderer. I want to change the thickness of these lines based on the distance of the freeway. So a freeway is something like I-605 for close to Los Angeles. It's a tiny bit of a highway that just connects two different highways. It's going to be really thin compared to I-10 that runs all the way from Los Angeles to Miami. It's going to be pretty thick. So that's the basic logic here. To get that, you need to, if you had to do all this by yourself, you would have to say, these are my class breaks. 100 to 200 miles should be one color, 200 to 400 miles should be another one, 400 to infinity should be another size. So you got to go ahead and try to define these kind of class breaks, and you have to go through the decision process of trying to find, how do I slice my data up? What kind of distribution do I use? Do I use normal distribution, or do I just make sure that there are all different kinds of colors, all different kinds of thickness kind of show up? You have to go through that process, right? But with smart mapping, you just delegate all of that to ArcGIS, and you say, ArcGIS, go ahead and decide how to use the class breaks. All I need to do is visualize by varying size of thickness. And that's what this particular statement does. So I can run this one, go back to my map, and you see it's, right now it looks all thick, but I can zoom into some place, something like Southern California, close to Los Angeles. You'll start to notice, yeah, this is the place I was telling you. You see with varying levels of thickness. Let me change the base map color so it's a little bit easier to see. Light gray maybe. Oh, oops. I'm so sorry about that. Let's find out what all base maps are available. We have just gray. Okay. I can do a gray vector. So you might be able to see this here. We have different levels of thickness and also a little bit different levels of colors going on there. As you zoom out, you'll start to notice highways that run for different lengths or of different thicknesses. So that was one quick way of visualizing line features and changing the thickness and visualizing it. You could apply the same logic to points as well. You could change point size based on a quantity that it measures. So let us see how we could visualize area features. So one easy way to visualize area features is to vary the color of the polygons, and that's what we're going to see here. I'll pull up a map of California. Let's get USA counties layer. First one will do for us. That's the counties item. I can go ahead and remove these cells so we can. I'm just removing these cells so we can have map and the code next to each other so we don't have to scroll too much. Once again, we go through the process of finding what all columns are available in our data set. So we determine which numeric column to use or which categorical column to use. There are a whole bunch of columns in this. It's census data set, so you can expect to see population different years, population for different ages, and so on. We can even visualize as a pandas data frame, just visualizing the top 5 rows. There are 52 columns, and these are it's just a sneak peek into that data set. What we could do is, let's get here, create another map. You could go ahead and add the counties, and I'm giving a class color renderer. I'm choosing population in 2012 as the variable to use. So this color map goes from yellow to blue, meaning blue represents counties with higher amounts of population, larger population. Yellower counties just represent lesser population. So this is where you're visualizing the whole United States, and your renderer changes to fit the whole data set. Imagine the amount of time it would have taken you to specify the class breaks all by yourself. Here you're just asking ArcGIS to do it. Well, the Python API is really delegating all the rendering logic to JavaScript API. So as JavaScript API improves and gives you better rendering capability, Python API will leverage on that, and we will improve how you experience that in Jupyter Notebooks. And that's what you're seeing here. You can mix and match definition queries into this. So here I'm pulling up another map. If you just want to visualize California, to the same renderer code, you just add this one line of code that says definition expression, and whatever definition expression is, state name equal California. State name is the column name. California is the value. And go ahead and run it. You'll just see that for California. So that was an idea about how to visualize using class color renderer. Now another renderer is heat map renderer that is used to visualize density of points, density of features. So let's try to use point data set for that. Living in Southern California, a constant fear and constant worry for me is earthquakes. So let's try to visualize earthquake data set and see the density of earthquakes as heat maps. So I'm just searching for earthquake data set from my portal. And as you expect, you can just call renderer heat map renderer. Earlier we said renderer class color renderer. And then even before that we said renderer class size renderer. Now I'm calling heat map renderer and giving it opacity. It's optional. You don't even have to do that. And start to notice earthquakes. You could zoom out, and this renderer will apply for the whole extent of the data set that you're viewing here. You can zoom out all the way, and you'll start to notice a circle of fire around the Pacific. Yes. So so that covers quick and dirty mapping with the Python API. You are completely delegating how to specify the colors to ArcGIS, and ArcGIS tries to make sense of your data set and tries to choose how to make the class breaks, and it applies and gives you a map back. Whenever you're working with a map widget, you can easily save this out into a web map just by calling any map object.save and give it some details. This is going to give you a web map back. So you can add as many layers as you want, imagery layers. You can draw graphics on it. You can do as many renderers you need, and then you can persist all of that as web maps. So if you close the web map, if you close the Jupyter Notebook, you can still have your product out as a web map. So that covers an introduction to mapping and visualization using Python API. Now to get a little bit more deeper into customizing the renderers, I'm going to hand it back to Andrew.
All right. Thanks, Emma. So before we dive into rendering, we're going to actually look at a new data structure that it's been around for a while, but we're starting to really promote it, and that's the Spatial Dataframe. And what we're going to do is I'm going to tell you that it's extended from the pandas. So if anybody here familiar with pandas, just real quick. So it's an extension of pandas. It's basically pandas, so you have all the power of pandas plus the power of ArcPy next to it on a geospatial column. You have the ability to import and export data, visualize data, and manipulate data. So there are some caveats with it, and it has to do with geometry engines. If you don't, by default, it'd be nice Maybe you work on a system, it's Windows, and you can use ArcPy, but maybe you're working on a Mac or a Linux system, and you don't have the ability to have ArcPy. You can actually use this system and leverage Shapely on top of that. Now, you get a subset of the functions that you can use. You still get your basic geometry options, your disjoints and operations like that, so you can leverage things for spatial queries, do simple spatial selections and buffers, but you lose some of the additional functions that ArcPy gives you on their geometry object with functions like distance to, how far along the line and stuff like that. You would all have to write that yourself if you were using Shapely. And then you can even use it without a geometry engine at all. And we'll do an example where we don't leverage anything from the geometry column at all, except for the JSON that gets stored in there that represents your geometry. We'll show how even if you don't have anything, you can still leverage this data structure to do very powerful analysis in a few lines of code. So the spatial data frame, working with the geometry, like I said before, it supports the simple points, lines, polygons, and multi-points that you're all used to with your feature classes and all desktop data, and also with your online data sets. Another problem is a lot of time you have CSVs, and this starts getting into the data science, data wrangling part of probably your day-to-day jobs if you're in that field, is how do you convert XY data into geometries? So here we have a CSV data going off the theme of earthquakes with ATMA, and they have latitude, longitude, and coordinates. You can create points out of them by simply going over your records and generating a point object. You specialize a spatial reference, and you tell it which row has your X value and which one has your Y. You then pass your original data frame that we used before when we imported your CSV and a collection of geometries, and now you've spatially enabled your pandas data frame. I mentioned before that ArcPy gives you some additional functionality, and this is why I think you should use it, and especially when you start doing spatial analysis. You have the ability to call functions like distance to, where you can take one geometry object and you can compare it to another. But not only can you compare just one geometry to another, these operations can happen on the whole column at once. So if you have 1,000 rows in there, you don't have to write a loop. You just say dataframe.column name, or scf.geometry in this case, and you can put your other geometry in as your input, and you get back another series that you could either put into your spatial data frame or leave off and continue on with some other workflow that you have. The spatial data frame supports multiple ways that you can import data. In this example here, we have a published item, in our case a hosted feature layer, and we're accessing the layers properties, and then we're querying that information. In the second line, we then say, feature set from the query results, I wanted you to make it into a spatial data frame. It converts all that raw JSON that's underneath, and it converts it into our spatial data frame object, and we can go on and continue our analysis. So that means you now have information that was sitting somewhere out on the internet. You now have it stored locally. It's pretty cool, pretty powerful, and you can start doing your analysis with it. It also supports a wide range. If you have ArcPy, it supports any data set, any data type, so any feature class that ArcPy can import. In this case, I'm just reading from a simple file geodatabase, and I'm importing it in. But if I had a shape file, I could import it that way. If I had an enterprise geodatabase and I'm importing that feature class, you could import that in too. And you could do your manipulations on the data set, especially if you only have read-only access to that data, do your manipulations, and you wouldn't affect the underlying data set. You can also export information. So once you have it into the spatial data frame, you can export it back out. Here we support 3 packages overall. You can have PyShape only, so you can, if you're working on a non-Windows system, you can export it to shapefile using PyShape. We support Fiona, for exporting shapefiles into file geodatabases. And we also support all the export formats that you can do with ArcGIS. So you get everything, it's sort of like a downward triangle. If you have ArcGIS, you get everything, and as you move down and you get closer to the bottom, it gets more and more restricted. But it allows people who don't work in the normal Windows environment to have more options, basically, that they didn't have before. So another thing that you can do with a spatial data frame is you can say, I have this spatial data frame and I want to save it as a hosted feature service layer, or hosted feature layer. What we did is we took the grid data set that we imported as a couple slides back from the file geodatabase, and then I'm hosting it on ArcGIS Online organization. It went through the whole publishing process. So that means you could take data set that's local, manipulate it how you want to do it, maybe get some results from some analytics that you run on it, and then publish that information directly without ever having a flat file on your system or having to store it permanently somewhere. So going back earlier, I said when we showed you can do the better matplotlib slide, I want you to pay attention to that, and because this is where visualization starts with a spatial data frame. These things can be put on a map. You can take a map, and you can just do something as simple as scf.plot kind map, and then you pass in your map widget, and it puts points on there. This is fully customizable, and it follows closely similar to the matplotlib syntax. And this is a very simple example just how to get the information on the map. So we created a whole host of ways that you can define colors and add them in. The very basic thing is you can pass RGB and A, so red, green, blue, and alpha values in as a list. But the other thing you can do is you can use pre-selected palettes that we came up with. And here's just a small selection of the palettes that we have available. So any of these names that you see on the left is what you would use. You would say palette equals, and then you would put one of these color schemes in, and it would automatically render your data. Now, you can let the system decide what color you want, or you can specify a range that you want it to even randomly select from, or you can say, I know in this palette I want, they're numbered from 0 to 255, I want number 125. And as you go down, you'll see that there's some pretty defined, well-defined marks in there that you can have. So this is basically the whole thing. But let's say we went through that list and we found a couple that we wanted. We like dark 2 and set 3 R. R means that it's just the reverse of the other way. So you can just query those and it'll bring up the individual ones that you have. We support, just like smart mapping, we support all the renderers out there. We support class breaks, heat map, simple, temporal, unique, vector, and predominance. Using the renderers, you basically define it when you call the plot method. In this case, I took the same data set and I plotted it twice, and I let the system decide how I wanted to do it. And by default, this doesn't produce probably what you wanted with a heat map or the points underneath, but it shows the possibilities of what you can do with it. You can change your blur radius, or you can go in and you can change your simple rendering type from diamond, to, I don't know, one of the other ones. Hold on. Sorry, I don't want to play or mess around. Or you could change the marker size, the opacity, you could, and the information along with the blur radius, and affect how intense or how fast the blur dissipates as you go through. So the next thing that I want to talk about, is applications of the spatial data frame. And and that story is basically this, is how can we, let's assume you work in an organization and you have 2 data sets. Let's say they're street networks for the same city, but from different sources. Let's say you have an authoritative state data set and you pull down your data from OpenStreetMaps. And you wanted to see maybe how off is OpenStreetMaps? Is the open source community driven product any better or worse? How can we do that? And let's assume for this that we maybe are a Mac user, so we don't have geoprocessing available, or we're running this on Linux, or anything else. We just don't have ArcGIS. So there's a bunch of different ways you can do this. You can visually examine your data, but that doesn't give you any metrics. It's also scale dependent, so as you zoom in and out, symbols will change. They render, they get thicker and thinner, so you can say, oh, over there in the corner, maybe there's some changes, and they don't overlap processing. The next thing you can maybe use, you're going to use geoprocessing. You bring it over to your Windows system, and you do an erase, and you look at your fragments, and you go, oh, well, Main Street has a little extra tail or something. But then there's also more quantitative ways that we can do this analysis. So this brings to the next thing. So I wanted to talk about challenges. The first thing is that the OIDs might not match, or either a unique ID or the OID is two things, and that's probably expected. They're not the same data source. So there's no way of matching them up. Your fragments are just fragments, they're just things. You might have projection issues. One might be in Web Mercator, one might be in WGS 1984, one might be in some state plane local feet, so that can be a big issue. And then you might have non-uniform tabular data. They just don't line up. That goes back to not having the unique ID. Maybe the street names are spelled differently. You were thinking, well, somebody spells out street, the other person just used ST period, and one person used ST not period. So how can we use these? And one way you can compare shape similarity is you can use Fréchet distance. And this is simply, when you think of Fréchet distance, you can think of it like this. Suppose you have a man and a dog. They're walking. And the man and the dog each walk on separate paths. They can either be polygons or lines in this case. Both the man and the dog can control their own speed. So that means they can walk independently at independent speeds. Now this is the high level. This isn't actually the way the algorithm actually works. But the only rule is that they can never go backwards. The Fréchet distance of these two geometries is the minimal length of that leash that is necessary for them to be able to make it to the end of the path without hitting a side or being forced to go backwards. So when you start comparing geometries, they're not quick processes. They take a lot of operational time. Often, this one essentially runs in a big O of n times n, where n is the number of vertices on where the man's walking, and m is the number of vertices where m is walking. So it's exponential. It's actually pretty good compared to other processes that are out there. It uses simple distance, Euclidean distance in this case, to do your measurement. Because our data in this example is going to be in projected. Yeah, it didn't show up well. So I'm going to dump out of this. So I want to show the code for the distance. I apologize, the screen resolution. So here we have the distance formula. It's just a simple that we all probably remember from our high school math. Then we get down to right here, and this is our actual implementation of the algorithm. We have our 6 cases where you can either walk back or what? Oh, zoom in? Sure, sorry. So it holds the cases. You have to have the case, you have your base case, and then you have your else, which says you can't get from here to there without crossing it, without going backwards. So that's where the float infinity means. And then what we do is we go to our next step, and this is where we pass the collection of objects or arrays from, we pass our objects as array objects for our first one, and then our second one, and we do the actual calculation that passes it into the _C. We take this information, and we're going to take our 2 spatial data frames. In this case, I don't have ArcGIS. installed when I do it. We're going to visualize it. Just a small subset. When nothing goes right. So here, we haven't done any analysis, and this goes back to the point where if you're visualizing it and you just look at it, you can see that you have a line here and you have a line here that look off, but you don't know how much they're off by. So we're going to, oops, sorry, didn't run it. Somebody should tell me I need to run my code. Thank you. So we run our code, it does the Frichet, and then we put the results back into a data frame. I then group it by the source ID, so the one that we want it to be the authoritative source, and we're going to compare the distances to to our non-authoritative source. By grouping this, we can use the minimum distance between the two and show which ones were the closest from the new imports. Now that we have all the ones that we know where there's the difference, we can either go back and further examine to see if our data is off, because maybe they did it better, or we can say that their data doesn't match up enough. It's just another way of taking data and doing things that you might not have thought were possible, and you can even go back and you can visualize that. So we can take that same map, do a little rendering on it, and we can show the areas where we have differences quite easily. So these are the features that we need to go back and maybe give to our GIS team and say, hey, these don't line up. Who's right here? All right, Emma, I'm going to hand it back to you. Thank you.
Cool. 8 minutes. All right, so let's switch gears here and look at how we can. We spent a lot of time looking at how to visualize feature data using smart mapping and then using custom renderers using the spatial data frame. Now let's see how we can visualize imagery data and raster data with the Python API. Here again, we are going to build on the concepts that ArcGIS already provides us, the JavaScript API for the map widget, as well as the raster functions for imagery layers in ArcGIS. So I'm going to search for Landsat imagery layer. This contains Landsat satellite scenes. I'm picking up the Landsat 8, which is the latest Landsat. And let's start working with that. Let's take a look at these items. When you just query the Landsat layer, this is an image. This object of type imagery layer. So I can do a type on L8. And you get imagery layer object. When you just query the imagery layer on a Jupyter Notebook, you get an image representation of that. It's just a screenshot of that for you to quickly visualize what it is. And then you can throw it on a map and make it interactive so you can zoom into any extent of your choice and it'll start to render. What we're going to do is explore the concept of raster functions. These imagery layers can have a concept of raster functions. The easiest way to understand raster functions are like filters. If you're using Picasa of those days, the application Picasa, or if you're using Instagram, these are also said to be called as filters on Instagram. So you can apply these, and then they get visualized. They get rendered only when you visualize that image of that extent. You don't create intermediate imagery products by running it on the source resolution. You don't create intermediate raster imagery layers. You can slap a lot of raster function one on top of each other, pile them up, and then when you visualize and extend, let's say, Palm Springs, only to the pixels that are on your screen that you have visualized, these raster functions get executed. These filters get applied. These tint and hue and everything that you control gets applied, and you visualize only for that extent. So they're extremely performant for you. So let's take a look at this. I'm going to go ahead, inspect the properties of this Landsat layer, and I have a bunch of different raster functions. The Landsat has around, I think, around 13 different channels or bands. And just by changing the band combination, you can have different kinds of imagery products that are best suited for a particular application. One for visualizing agriculture, one for bathymetry, one for color infrared, once again to visualize wooded areas, vegetated areas from non-vegetated areas, some things for geology, and so on. So what we could do is combine scripting and this raster function, and we can write a little small loop. And we can loop through those raster functions and render the same satellite image of the same extent onto this area, and we can start to visualize how they appear. So that's what I'm going to do here, is agriculture, bathymetry, color infrared, and so on. So what I'm drawing here is not just for that, it's just for that extent, whatever that is visualized here. So I can zoom out and you can see it takes a little bit of time for that. It starts to render for that extent. So this imagery layer came with a whole bunch of different raster functions, and that's what we are seeing it. Just by changing the band combination, we are able to visualize different effects. But you're not limited to what comes with that image, so you can go ahead and define something for yourself. So what I'm doing here is soil adjusted vegetation index. If you notice, this is not part of what comes with the imagery. So I can compute myself, create my own raster function, and ask it to render using my custom raster function. So that's what we're going to do here. Let's create a map for Egypt. Let's add the same exact layer. Now, even looking at this raw imagery data, you can see that this is the Nile Delta. You can see the vegetation and the historical civilization that would have happened along this delta, along this river. You can see that the fan of the Nile River is so rich in vegetation. Now I can take this further. I can define my own raster function, have a combination of these bands, and I can apply this raster function on the fly to my map. And you see? So you're able to enhance the same effect using our own custom raster function. You're able to render that on the map, and you get totally new visualization. This is very performant because I do not download this image, or I do not ask the server to get this image and compute this raster function, create a new imagery layer, publish as a new image service, and then render it. That thing did not happen. It's just happening as you visualize to your map extent. So what that means is I can keep zooming this out, and I can visualize for the whole Earth. So I can come back to Palm Springs, where we are right now. And you should be able to see the Salton Sea somewhere here. Oh yeah, there we go. The rich vegetation in the downstream of the Salton Sea. So this was one quick sneak peek of the hundreds of raster functions that are available for you at your disposal, and the raster functions you can create yourselves and apply them with rendering time or drawing time computation, and you can render that in your map widget and visualize it. So let's change gears one more time, and let's look at, we'll do that? Visualization outside Python, outside ArcGIS? Okay. Okay, so let's change gear one more time, and let's look at how we can use third-party libraries outside of ArcGIS, and how we can use that to visualize your non-spatial data. So this is the point that we want to send across, is that the Python API allows you to do this integration with external libraries in a very easy manner. The pandas data frame and the spatial data frame that you saw is going to be your channel with which you can take data from your ArcGIS ecosystem, take it to other libraries which understand pandas, and use that to visualize. And if you want to, you can do computation like what Andrew showed, and you can bring it back into ArcGIS. So the spatial data frame becomes your vehicle to take data in and out of ArcGIS. So let's go ahead. This is what we saw earlier. I'm searching for the same counties layer, same item. Let's look at what all columns are available. And what I want to do is I want to look at population in 2012, and I want to create a bar chart of population in 2012 for all the counties that are in California. So to make it easier for me, I'm setting an index on the spatial data frame. Right now the index for this data frame is 0, 1, 2, 3, just numeric column. I want to use a name column. Name column is somehow hidden here. Okay, there's a name column here that contains the name of these counties. I want to use this as an index. So all my plots, my x-axis, will start to have the name of the county as the x-axis. So let's go ahead and run this one. So you just created a plot with population in 2012 by different counties. So we can take this further and we can look at how is population and square miles correlated. Generally, larger counties may have more population, but there may be some outliers. Like for instance, something over here where it's high in population, but smaller in square miles. So this is a county that has really, really high population density. So you can start to do this exploratory data analysis. And here I'm using a library called cbon, and I'm able to do a join plot. Join plot is where you take two variables and you put that into a scatter plot. In addition to that, on the top of the scatter plot, it gives you a histogram of that variable. Here's another histogram of that variable. Doing all of this by hand, even using matplotlib, is going to take you a lot of time. So you can start to use other higher level libraries like cbon and bokeh and plotly. We're going to see a little bit now after this. You can use those to quickly generate these kind of plots. You can do another plot. I'm just changing it to black and white ratio, and then you see there's a little bit of correlation going on. So it gives you, I don't know if you can read it there. Oh, you can. There's a Pearson R correlation and the p-value of that correlation, how confident it is about that. It just prints it over there. You can change and you can say, I think you can do kind equals hex, and then instead of points, I think it will show you hexagon bins. It's too tiny over here. But you could change these things and start playing with it and really create popping visualization effects. Here's another thing that you can do is, let's skip a little bit and get here. What you can do is, if you want to quickly find the correlation between numeric columns all in one shot, then you can do pair plot. And if I run it takes a little bit of time to run. But after I run this, it tries to create a plot like this. You have the vacancy, males, renter, households, median age. This is a census data set. These columns, and they are fitted against the same exact set of columns. And you will find the scatter plots of renter occupied houses versus number of males, renter occupied versus households, and stuff like that. So this is a very quick way to see how are these columns cross-correlated with one another. Or either any kind of interesting phenomena that is going on. If you see the diagonal is just the same variable plotted against the same variable. So cbon is a little bit intelligent in that part. So instead of giving you just a scatter plot of vacancy versus vacancy, it just gives you a histogram of vacancy. That's what you see here. So let us get to this part. One thing I wanted to show you here is that these are very static images, right? You cannot interact with it. But if you want to really interact with this, then we are going to use a new library called Plotly. Plotly is similar to how the Python API is built. It uses JavaScript for plots, so it becomes really interactive for you. And how you can save your maps in Python API as a web map, you can save your plots in Plotly as a plot object. So let's skip here and take a look at this. You got to go ahead and install Plotly and another library called Cufflinks, which makes Plotly talk with pandas data frames. So with these two libraries, I just went ahead. You need to create an account, a free account, and you get a key, and you need to sign in. This is not my actual key, I just a random number I threw in. This is the same USA counties data set that we just saw earlier, the same data frame. And I can do the data frame.iplot, and instantly I have a plot of all the different variables that are there. You can just go ahead, inspect. I think you can go and zoom this, and it becomes really, really interactive. And you can take it even further. Here I'm doing a bar plot of the same 2012 population. You saw that earlier in Matplotlib. Now we are seeing it in Plotly. You have the same different counties. Now you can hover your map, and you have an interactive plot. You can zoom in and find out what's going on here, and so on. Here's another interesting part. You can do an export to Plotly, and then what happens is it creates a plot object here. You can take this and say if you're building a blog site or a news site, and you just spend a lot of time creating a very useful and highly informative plot. And you can create that with Plotly, save it out as a Plotly plot, and embed that into your web pages or journalistic articles. And then it's a nice interactive plot you have on your articles, on your web server. That's another interesting way to do that. People can go ahead, play with your X and Y and try to see the phenomena that's going on. So let us stop here, and I'll hand it back to Andrew.
All right, so that's the point. We want to thank you for coming. We covered a lot of information, and we're willing to take some questions. We have a couple more minutes left. If anybody has them, please raise your hands. And nope. Okay. Oh, yes. Yeah, the notebooks will be available in a week or two on our github.esri / with the Python API website.
I'll just show you here.
Yeah, he'll show you where they're going to be. So, yes.
This is our GitHub repo. Just make a note of this repo. Go ahead, bookmark this or star this, and then look for talks. Not only this, everything we gave before this is going to show up. Everything we're going to give after this is also going to show up there.
Yeah, so you can't make UC, they'll be here. So, yeah, yes, sir.
When he was showing down visual layers and homology, it was very, very strict and said that ArcGIS will do everything for you. And told something that ArcGIS advice was supposed to send some data to ArcGIS and JavaScript API. That JavaScript API will apply some logic.
Yeah, so that was what Amma showed. That was using the smart mapping. And so that's the simplified. But if you know how you want your data to look and you want to have full control, you can also we also exposed a full rendering API that you can leverage to make your data, for the users who really want to get nitty gritty and down and dirty into their data and make it look the way they want. So there's two options. So.
Basically, they are much more
Yeah, well, for the, if you're going to compare JavaScript to Python, we don't have an interactive GUI. All the clicks and the drop downs that you do represent a variable within a bunch of information. So yeah, you have to type it in.
Yeah. Yep. So, you have to weigh between the ease of scripting and the richness of a full-fledged rendering software. So Python API, you shouldn't use Python API for the purpose of using ArcGIS Pro for visualizing and composing a cartographically rich map.
Yeah, you can open it up. You just have to download it, and you can then do what you want with it.
You mean the API or these samples?
ArcPy is not open source. The Python API is. Well, you're able to look at the source code, I guess.
Yeah, well, strictly it's not open source, but we don't stop you from looking at the code and seeing how it's implemented. You could certainly do that. Yeah, we don't. Yeah, it's not open source per se. It's not FOSS software.
Any other questions?
Yes. Oh, okay. Sorry if I forced you to ask.
Well, have you interacted with other people who are not ArcGIS API? This new module is available for them to use?
You mean the spatial data frame? Is that what you're talking about?
Or
we encounter tons of people that it's new. So a lot of people, not tons of people have. It's not like desktop, where probably everybody here is touched, or server. It's, but it's growing, and there's a lot of, I think there's a lot of excitement about it. We get good feedback, and the stuff that's bad, we try to fix. We try to be quick, nimble, and we want to make something that you want to use. So.
Is there any other, you guys created this spatial data frame, and now I asked you before about it, and now I see the full potential of it, and I think it's really cool. Are there any other data types, like geocases or something that is specifically geo data you can use?
Well, you could read file databases, shape files, and all those standard data formats with the Python API. You could do that. You could talk to once you make your data available as web layers, be it feature layers or tile layers, scene layers, map image layers, GP web tools or geoprocessing services, network analysis services, and all of those can be accessed with the Python API. Yeah.
Yep. All right. Any other questions? We'll take offline. We have to let the next people who are going to come up on stage. We really appreciate you all for coming, and we thank you for your time. Please take the survey. Like we said, we really value your feedback. It helps us get better, and it helps you guys see the presentations that you want to see. So, thank you.
Thank you.